This video is on the objective, understand all forms of the Pythagorean identity. This is number one, right, the first video here on a question from your Newton-Alta homework related to this objective. All right, so let's take a look at it. So again, if you're unfamiliar with the objective, hopefully you've read through section 9.1 in your OpenStax Algebra and Trigonometry book. Or you can look here at more instruction, right? See what kind of notes or videos or examples they have, and see if that helps. Hopefully that helps. All right, so we're saying here, it says, given that the cotangent of some angle theta is equal to -1/2, and theta is in quadrant 2, right? That means when you draw theta, if you were to draw angle theta in standard position, it would end in quadrant 2. What would be the sine of theta? And it says write your answer in exact form, do not round, right? So don't punch it in your calculator, right? Just write out what you get on by hand, right, with no calculator work. So we've actually seen this done before without the Pythagorean identities. But let me refresh your memory as to what the Pythagorean identities are. All right. So here are the Pythagorean identities. These are true for any angle thetas as long as things are defined, right? As long as these functions are defined. And this should just be a refresher. You should know, you should remember these hopefully from an earlier chapter. If not, you got them here, right? So the sine of any angle squared plus the cosine of that same angle squared will always be equal to 1. All right, so there's the first one that involves sine and cosine. The second one, if I take this first one, if you know the first one, I would definitely recommend memorizing this first one, because then you can very easily get the other two. If you take this first one and divide everything by sine squared, you're going to get 1 plus cotangent squared equals cosecant squared. So there's one that involves, cotangent and cosecant. And then if you take that first one again, sine squared plus cosine squared equals 1, and then divide everything by cosine squared, you're going to get tangent squared plus 1 equals secant squared. And you got this third Pythagorean identity with tangent and secant involved. So notice that each one of these involves two different trig functions squares and the number 1, right? Two different trig functions squares and the number 1, two different trig functions squares and the number 1, right? Every single one of them. All right, so now this particular question, again, we've seen how to do this in an earlier chapter without the Pythagorean identities. So I'll show you how to do that first, and then I'll actually get into how to do it with the Pythagorean identities. So without the identities, I would just say draw a picture, and you know me, I like drawing pictures of these angles. We're given this. We're given that the cotangent of some angle called theta is -1/2, and we're also given that theta, right, this angle theta, it ends in quadrant 2. Right. So what I'm going to do is I'm going to draw a picture of this angle theta, and we're going to set up a little right triangle in our picture. And again, you've seen me do this before in previous chapters. So there's the xy coordinate plane, and I'm drawing an angle in standard position, right? This angle theta. And so we're starting from the positive x-axis, and it ends in quadrant 2. Now I can go counterclockwise, I can go clockwise, it doesn't matter. As long as theta here, there's theta, as long as it ends in quadrant 2. Right, this is quadrant 2 here. With, you got negative x values, positive y values. Alright, now you remember what we did with these terminal sides of angles drawn in standard position. I'm going to take some point here. It has some x coordinate and some y coordinate, I don't know. and I draw a perpendicular segment to the x-axis, and that creates a right triangle with, the reference angle, I'll call it R here, R for reference angle, with the reference angle right there formed by the terminal side and the x-axis. So I got a nice little right triangle going. What I want to do is I want to find, what's the x coordinate of this point, the y coordinate of this point, and then how far is it from the origin. Right, what's x, y, and r, right? Little r, right? The radius of a circle that we're on. Okay, well, if the cotangent of my angle is -1/2, right, that means in my picture here, the cotangent of the reference angle needs to be a half, right? The positive half. Now, if you recall, cotangent, right, was adjacent side divided by opposite side. So on my picture here, I'll just have the adjacent length be 1 unit. So the adjacent length to the reference angle, this is 1 unit. And then the opposite side be the denominator, 2 units. So this is 2 units here on the opposite side. Okay. And like I said, now we have our x coordinate is -1. X is -1. The x coordinate of this point I picked here, and then usually I'll put like a negative in front of it on the picture because it's left of center. The y coordinate of this point is +2, right? The y coordinate is up 2. Right, and then I need the radius, right? What's the length of the hypotenuse, which I'll call little r. Right? And we can use the Pythagorean theorem, right? -1 squared plus 2 squared, right? The sum of the squares of the legs will be equal to r squared. And this is, 1 plus 4 equals r squared. So r equals the square root of 5. Remember, r, now technically it could be plus or minus the square root of 5, but we're talking about the distance from the origin. Remember, this r is always positive. So there's square root of 5. And now I have all the information I need to find what they're asking me for. They said they wanted you to find the sine of theta. And if you recall those relationships from earlier with x, y, and r on our pictures of angles, the sine of an angle was, the y coordinate of a point on the terminal side divided by that radius, divided by that distance to the origin. So here that would be 2 divided by the square root of 5. And it should be positive, right? It's in the second quadrant. Y coordinates are positive, sine's positive. And if you want to rationalize this would be 2 times the square root of 5 divided by 5. There's what they're asking for. This value right here is the sine of the angle I just drew. Right. The cotangent of that angle is -1/2. The sine of it is 2 times the square root of 5 divided by 5. All right. Now that's one way to do it, and I like this way. It's very simple, very easy. Drawing pictures, easy to look at. Now, let me do it another way. This time using these Pythagorean identities, using identities. Right, so this is with identities. And you'll see I'm going to end up getting the same value, I promise. Right? I'll end up getting the same value, 2 times the square root of 5 over 5. It's just a little more roundabout, and I'm not going to be looking at any pictures. So again, here's what we're given. The cotangent of this angle theta is, -1/2. Theta ends in quadrant 2, and that's it. Right? And we're asked to find the sine of this angle. All right. So this time, I'll show you how to do that with these identities. All right. So we're given the cotangent, right? We're given the cotangent. Now, if you look back at the Pythagorean identities, there was one of them involving cotangent, and that one involving cotangent also involved cosecant. So if I know the cotangent, I can solve for the cosecant. Right, so that's this one here. So I'm going to use the Pythagorean identity, 1 plus the cotangent of theta squared will be equal to the cosecant of theta squared. All right, so I plug in, now the cotangent of theta is negative 1/2, right? So we got 1 plus, and then the cotangent of theta is negative 1/2, and again, this is getting squared. And this should be equivalent to the cosecant of theta squared. And then we solve for cosecant, right? Now, this is 1 plus a fourth equals, cosecant of theta squared. And then that's 5/4 when you put it together, 4/4 plus 1/4. Now this is what cosecant of theta squared is. So cosecant of theta is equal to plus or minus the square root of this. Now, theta is in quadrant 2. All right, we got to remember, since theta is in quadrant 2, right, since theta is in quadrant 2, the cosecant of theta will be positive. Remember, because the sign will be positive. Right? In quadrant 2, signs are positive, so the cosecant, the reciprocal, will be positive. So when I'm like, hey, which square root do I use? Do I use the positive square root or the negative square root? I'm going to use the positive square root. Right? And again, that's because the cosecant of theta will be a positive number. So positive square root of 5/4, which, if I simplify this, is the square root of 5, divided by the square root of 4 is 2. And that's the cosecant of theta. And then we can use our reciprocal identities, right? Now that I know the cosecant of theta, then the sine of theta is just the reciprocal of that, right? The sine of theta would be the reciprocal of this, so instead of square root of 5 over 2, it's 2 divided by the square root of 5, which when rationalized is 2 times the square root of 5 divided by 5. Exactly what I got on the previous page when I drew that picture. 2 times the square root of 5 divided by 5. I personally like the pictures. But, these identities also work. You really have to focus on, what quadrant am I in? Should my final value be positive or negative? And it all depends on the quadrant that you're in. All right, so after all that, I've got my value. Right, so I go here, sine of theta equals, let's see, I think I can just enter 2. It didn't say anything about rationalizing the denominator, so I think I can just enter 2 divided by the square root of 5 and submit that. Excellent. Excellent. So you don't have to rationalize your denominators, I guess, if you don't want to. I mean, it would also take 2 times the square root of 5 over 5, as you can see down here. Right? But those are equivalent numbers. And they see how they use that identity, 1 plus cotangent squared equals cosecant squared, and going through the exact same procedure. And again, the cosecant ends up being plus or minus square root of 5/4, but you got to use the plus because theta is in quadrant 2, and cosecant would be positive, right? You got to pay attention to the quadrant. Great. All right, so hopefully this helps you when you're working on this particular objective, a question like this on your own. Again, practice using the identity. I know, like I said, I know you can do it with a picture. But practice the use of the identities. You need to know the identities anyway. So if you practice writing them out and using them, hopefully that'll help you in remembering them and memorizing them. And thank you very much for watching.